Hello everybody, and welcome to topic number 1, solving linear equations. In this topic, we have a bunch of objectives we're trying to show you. We're going to show you how to solve linear equations using different properties of equality by balancing the equation. We're going to show you how to solve linear equations that can be simplified by combining like terms. We're going to go through and work with linear equations that involve fractions or decimals. And we're going to be able to recognize linear equations that have both real and no solutions. As we go through this, here are some general guidelines for solving a linear equation in one variable. Not all of these steps will be present, but this is generally the order we want to go in when we're looking for things. The first thing we want to do is look to clear any fractions or decimals by multiplying by the LCD if possible. If we don't have any fractions or decimals, we'll look to distribute, if possible, by removing any parentheses. We'll then combine any like terms that are on the same side of the equation. We'll get the variable by itself on one side and the constant terms the other side. We'll isolate the variable, and then we'll check our solution if needed. So we're going to follow these steps as we go through and solve each of the problems. Let's work through some examples, and we'll get progressively harder as we go through. In this problem, we have 2x plus 5 equals 9. And a lot of the times throughout these, if you're just beginning or you need help, I like to draw a line down the equal sign so that you can clearly see that there's a left and a right side. Our job is to get the x by itself, and right now the x is on the left side next to the 5. In order to do this, we're going to have to move the 5, which is a positive 5. In order to get rid of the positive 5, we're going to subtract 5. But whatever I do to one side of the problem, I'm going to do the other. So I subtract 5 from both sides of the line. On the left side, the 5's will cancel out, and I just have the 2x left. We'll bring down our equal sign on the left. And on the right side, we've got 9 minus 5, which is 4. Now we've got 2x equals 4, and our job is to get x by itself. Here this says 2 times x on the left side, and the opposite of multiplying is dividing. So we're going to divide both sides by 2. Again, remembering whatever we do to one side, we're going to do the other. Over here, the 2's cancel, and I'm left with just x. And on the right side, 4 divided by 2 is equal to 2, which leaves me with my final solution that x is equal to 2. If we wanted to go back and check, we would do 2 times 2 plus 5. And our job is to see if it equals 9. We know that 2 times 2 equals 4, and 4 plus 5 does equal 9. So we came out with the correct solution. Our next problem involves decimals. Now you could solve it similar to what you did with the other one, but our goal with decimals is to first see if we can go through and remove the decimal points. To do this, we're going to have to see how many times, at most, we have to go through and move the decimal to make it a whole number. When I look at the two values that have decimals, I notice that if I move them each one time, they become whole numbers. So when I move this 0.6 and I move the decimal, it now becomes 6. And when I move the point on the 5, it becomes 35. I'm going to have to do the same with 2, because whatever I do to one part of the problem, I have to do to all. So I'm going to take the decimal point that's not there. I'll put 1 right after 2, and I will move it one time. And since there's no number there, we're going to fill it with a 20. Now we can go through and solve like we did the other problem. Our goal is to get x by itself, and x this time is on the right side, and it's attached to the negative 35. So my goal is to move that and get rid of it last, which means I have to get rid of this 20 here. Now there's no sign in front of the 20, so we assume it's a positive 20, and the way to get rid of a positive 20 is we're going to subtract 20 from both sides. I subtract 20 from both sides, and on the right side, it cancels. Something should always cancel out when you're solving this. So I have just negative 35x here. On the left, 6 minus 20 equals negative 14. Again, my job is to get x by itself. I notice x is on the right side attached to the negative 35. It says negative 35 times x, so I'm going to divide by negative 35 to cancel it out. But whatever I do to one side, I'm going to do to the other. So I'm going to have x equals, and then I'm going to look to simplify this. A double negative will become positive, and we'll have a fraction 14 over 35. Our job is to see if 14 over 35 can reduce, and we notice that in both of these problems, they're both divisible by 7. 7 will go into 14 twice, and 7 will go into 35 5 times. Therefore, my final answer is x equals 2/5. It does not matter which side you solve the variables on for a linear equation. On the first problem, we solved it on the left side. On the second one, we solved it on the right side. You still get the same answer either way. Moving on to the next problem. In this one, we just happen to have variables that are on both sides of the equation. We have multiple of them. Our job is to get them down to one variable on one side. The first thing we're going to do is combine any like terms. Something is considered a like term if it is on the same side of the equation. On the left side, we have two like terms. We've got the negative 4x and the 5x. Those will combine. We won't use opposite operations. We'll just combine them as is. Negative 4 plus 5 will give me 1x. This negative 1 doesn't combine with anything, so we're going to go through and drop it down. We'll do the same thing on the other side. We're going to look for like terms. So on the other side, we have a 9x and a negative 7x. Those will combine. 9 minus 7 gives me 2x. Again, the 3 doesn't have anything it can combine with, so it will drop down as part of the equation. Now we have x's on each side, and we have constants on each side. We have no more to combine, so we'll move on to the next step. Our next step is to get the variable on either side of the equation. And as we do this, I always like to move the variable that is the smallest. So we're going to go through, and we're going to move the smallest variable. When you look, I've got 1x and 2x. Well, 1 is smaller than 2, so I want to move the 1x to the other side. To get rid of the positive 1x, I'm going to subtract the 1x. And I'm also going to subtract it from the right side. Now I'm going to make sure I subtract it with the 2x because those are like terms. We always move things and combine it with its like terms. On the left side, this cancels, and I bring down the negative 1, which I did not touch. Over here, 2x minus 1x is 1x. The 3 I did not touch, so I will bring it down. My goal now is to get 1x by itself, which means I have to move the 3 since it's on that side. This shows a positive 3, and in order to get rid of a positive 3, we're going to subtract 3. But whatever I do to one side of the problem, I've got to do the other. Here the 3's cancel, and it just leaves me with 1x. Here I've got negative 1 minus 3. That becomes negative 4. My job is to get x by itself. This says 1 times x, so I need to divide by 1. But anything divided by 1 stays the same. So my final answer here is x equals negative 4. So as a reminder, when you combine like terms, you combine them with the signs that they are. So I got a 1x from the top by doing negative 4 plus 5x, and I got a 2x from doing 9x minus 7x. In this problem, we have a set of parentheses, which means we need to remove them first. We're going to do that by distributing. The way we distribute is we go through and we take what's on the outside and we multiply it by everything that's on the inside, which I'm indicating here with the arrows. So I'm going to do 2 times x, which just gives me 2x. And then I'm going to do 2 times negative 3, which is negative 6. I don't do anything with the other side, so I just drop this down. Again, my goal is to get x on one side, and I take a look and I say I have a 2x and a 5x. The 2 is the smaller value, so I want to move the 2 instead of the 5. This is a positive 2x. In order to move a positive 2x, I need to subtract the 2x. I'm also going to do the same to the other side, making sure I subtract it from the 5x because that's its like term. I drop down the negative 6. Here I've got 5 minus 2x, which is 3x. I'll also go through and drop down the negative 9. The 3x is on the right side, so I need to get that by itself, which means I need to move the negative 9 here first. Since this is a negative, the opposite of being negative or subtracting is adding. So I need to add 9 to be able to cancel it out. But whatever I do to one side, I will do to the other. The 3x will drop down here. Here I've got negative 6 plus 9. That will give me 3. My goal is to get x by itself. It says 3 times x. The opposite of multiplication is division. So I will divide, and I get my answer to be x equals 1. Remember, you can write this either way. So either one of these ways with the x first or the x second is correct. As we come to this problem, we notice that there are fractions now. Now, nobody likes to work with fractions, so our goal is to get rid of them as quickly as possible. To do this, we're going to need to find a common denominator. We need to find a denominator for any denominators that we currently have. So right now we have a 3, a 4, and a 6. So I need to find the least common denominator that goes into all 3 of these numbers. Typically, I like to take the biggest number and find its multiples and then see if the other 2 numbers go into it. So for example, with 6, while 3 goes into 6, 4 does not go into 6 evenly. So the next number I will look at is 12. 6 goes into 12 evenly, 4 goes into 12 evenly, and 3 goes into 12 evenly. So in this case, our common denominator is 12. Once we find our common denominator, we're going to use that to help get rid of these fractions. We're going to take each of these fractions and we're going to multiply it by the common denominator. By doing that, we'll be able to get rid of the bottom as we do this. So as I multiply, we'll go top by top and we'll divide by bottom. So here I've got 12x over 3 minus 12x over 4 equals 12 times 1 is 12 divided by 6. Now these should be able to simplify. 12x divided by 3 gives me 4x. 12x divided by 4 gives me 3x. And 12 divided by 6 gives me 2. Now I no longer have to work with any fractions. I can solve this like the problems that we've done in the past. These 2 parts here are on the same side, so we're going to combine them because they're like terms. 4x minus 3x gives me 1x. So I have 1x equals 2. And my goal is to get x by itself, so I will divide by 1. In this case, we get x equals 2. So again, our job here is, whenever we work with fractions, to try to find the common denominator so that way we can get rid of the fractions very quickly. We're going to do the same idea here with this problem. We're going to find its common denominator and try to clear that off quickly. So when I look here, I have 2 denominators at the bottom. I have a 2 and I have an 8. Notice that the 2x does not have a fraction. If we want to, we could put a 1 underneath it, but it's not going to make a difference because 1 can go into any number. So my job is to find a common denominator. What number can both 2 and 8 go into? If I start with the biggest number, 8, I know that 8 goes into 8. I also know that 2 will go into 8. So in this case, 8 happens to be my common denominator. What we're going to do is we're going to take each of these parts and we're going to multiply them by 8. Even the part that did not have a denominator. Everything has to be going through and be multiplied. In this case, let's see if we can cancel out the bottoms right away. We know that 8 divided by 2 becomes 4. And the only thing we have left after we cancel that out is the numerator, the x plus 5. Same thing here. We know that 8 divided by 2 gives me 4, but I still have the times 1 left at the top. 8 divided by 1 just gives me 8, and then I have a 2x minus. Here the 8's completely cancel, so the only thing I have left at this part is the x minus 3. Now we've done a great job of getting rid of all the fractions. Let's go through and distribute and get rid of all these parentheses as we can. So in this problem, I'll go through and distribute the 4 into this. 4 times x is 4x. 4 times 5 is 20. Here, this is just multiplication. 4 times 1 gives me 4. Drop down the equal sign. Here, this is multiplication as well. 8 times 2x gives me 16x. And then here, we have a negative sign outside of a parenthesis. This is also distributive property. And since there's no number there, if we don't see a number, we're just going to assume that it's a negative 1. So we're really going to distribute a negative 1 into this parenthesis here. So when I do that, negative 1 times x gives me negative 1x. And then negative 1 times negative 3 gives me positive 3. Remember, negative times a negative turns back to be positive. Now our goal is to see if we can combine like terms. So let's look at each side and see if we have any like terms. On the left side, nothing combines with the 4x, but the 20 and the 4 can combine. The 4x will come down, and 20 plus 4 will give me 24. On the right side, we can look again and see that these two values both have x's, so they can combine. The 3 doesn't have anything it can combine with, so we'll end up just dropping it down as we do this. 16x minus 1x is 15x. And then we're going to drop down the 3 from here. I'm going to rewrite the problem from this point over here. And then our goal is to solve for x. Remember, I want to move the 1 with the smaller x. So between 4 and 15, I'm going to move the 4 to positive 4. So in order to get rid of that, I should subtract it. The 24 comes down. 15 minus 4x is 11x. And the 3 will come down with it. The 11x is on the right side, so my goal is to get the x by itself on the right side. I'm going to move the positive 3, and I'm going to do that by subtracting. 24 minus 3 equals 21. And then the 11x comes down here. My job is to get x by itself. It says 11 times x, so I'm going to divide by 11. Now in this case, I look at 21 over 11. 11 doesn't go evenly into 21, and because 11 is prime, this won't reduce. So this will in fact be my final answer. So with fractions, our job is to find a common denominator. Let's find a denominator to be able to get rid of the fractions and make the problem easier for us to solve. Here we have a problem similar to what we saw earlier. Our job is to be able to move the decimal points and be able to get rid of them so that we can solve it. When I look at each problem, I see one number after the decimal point except for the 27. That one, I see two numbers. So that's the most amount of times I've got to move the decimal point in order to get it to be a whole number. Since I have to move that one twice, I've got to move everything 2 times. So I will do it for the 0.02, for the 0.3, and the 0.1. Now for the 0.3 and the 0.1, we have open spaces. We're going to fill those open spaces with zeros. So because I have one open space by the 0.3, this will really be 30x. And I have one open space after the 0.1, so this will be 10. The other side, I moved it twice. This is now 27x. And over here, it's now minus 2. And now we don't have to work in decimals. We can go through and solve the problem without it. My job is to move the smaller of the two x's, so I have 30x and 27x. I'm going to move the 27x. It's a positive 27x, so I'm going to subtract it from both sides, making sure I subtract it from something that is its like term. 30 minus 27x is 3x. We drop the 10 down with it. The 27x is canceled. Here I'm going to drop down the negative 2. Make sure we drop it down as a negative 2. That minus sign really ends up becoming the negative at this point. I've got 3x on the left, so I've got to move the 10. Right now it's a positive 10, so I'm going to subtract 10 from both sides. The 10's cancel here. I don't do anything with the 3x except drop it down. Negative 2 minus 10 gives me negative 12. Finally, I've got 3x equals negative 12. I've got to get the x by itself. It says 3 times x, so I will divide both sides by 3. On the left, I've got x. I've got negative divided by a positive. A negative divided by a positive will always come out to be a negative number. 12 divided by 3 is 4. So again, use this idea of being able to move the decimal points to be able to turn it into whole numbers. Working with something with whole numbers is a lot easier than working with something with decimals. Just make sure you have to move all the decimal points the same amount. Our last two problems have us take a look at different ways that linear equations can end up. So everything we've done before, we've gotten a solution, but not all linear equations are going to have a solution that's as easy as just a number. Let's take this problem for example. So in this problem, we have a parentheses on the right side. So we're going to go through and we're going to distribute to get rid of that parentheses. We don't do anything to the left side, so we'll bring it down. 3 times x is 3x, and 3 times 2 is 6. Now I try to move the smaller of the x's, but if you notice here, the x's are exactly the same. I have 3 x's on both sides. So when I try to move each one of them, both of them are going to end up canceling out. So what am I left with? I'm left with the equation 5 equals 6. Now, I don't have any variables left, and all I have is just this idea that 5 equals 6. So at this point, you've got to ask yourself, is this true or false? Does 5 equal 6? If you have 5 of something, is that the same as having 6 of something? Well, this is false. You can't have 5 equaling 6. If you have 5 pencils, then you do not have 6 pencils. So what does that mean for us? Well, for us, that means that there is no solution to this problem. There's no value of x that I can go and plug in, and I would make the variables, and I would make the equation equal to each other. So we just simply call this a no solution. So in order to get a no solution, we have to have the variable cancel out. So we'll have the variable cancel, and then we'll have something that is a false statement. So in this case, we got that 5 equals 6, which is clearly false. What happens if it doesn't come out false? Well, let's take a look at this problem. So in this problem, we have 6x minus 4 equals 2. 6x. Oops. We have 2 plus 6x minus 1. So let's distribute into the parentheses here, just like we did. The 6x minus 4 doesn't do anything. We don't do anything with the 2 as well, but we'll distribute the 6 into the parentheses. We have 6 times x, which is 6x, and 6 times negative 1, which is negative 6. If I look here on the right side, we do have some like terms. We've got a 2 and a negative 6. Those can go through, and they can combine. The left we still don't do anything with. We have 6x minus 4. We don't do anything with the 6x, so we can drop it down, and 2 minus 6 is equal to negative 4. Now, again, we're going to try to move the smallest x, but we notice that the x's are exactly the same. So when we try to move it, it just cancels out both x's, and we just bring down the numbers that we have left. In this case, we have negative 4 equals negative 4. Now this time I would ask, does negative 4 equal negative 4? And we would say, yes, this is true. If you have a number and it's the same, it equals itself. So in this case, it's not actually no solutions. That means the answer is all solutions. It does not matter what value you put in for x. As long as you put in the same value for both of the x's in the original problem, you're always going to come out with something that is the same. So how did we get all solutions? Well, again, the variable canceled out, just like the last problem. However, this time we were left with a true statement. So if you get a true statement, you have all solutions. If you get a false statement, like we did on problem 8, now you have no solutions. If you get something like the rest of the problems where you solve for the variables, that means we have one solution. And those are the only types of solutions we can have in a linear equation.